Today we're going to move into a discussion of parabolas. The definition of those parabolas is as follows: the set of all points equidistant from a given point, which we call the focus, and a given line, which we call a directrix. Now you can see I've got two parabolas drawn right here, and that distance that we're talking about is that focus point. If you take and put any point on the parabola, find its distance, then that distance is going to equal the same distance I would get from drawing a straight line to the directrix. Obviously, that straight line's got to be a perpendicular. Shortest distance is that perpendicular. So these two are going to be the same. And that would be true for anywhere along this curve. Okay? You'll notice, in fact, that this distance is probably going to be the most important that we talk about, the distance from the vertex to the focus and the vertex to the directrix. All right, we've got all of our standard points in here as well. There's your line of symmetry, all right, and so on and so forth. So let's take a look. General equations. So if we have a vertical line of symmetry or a vertical parabola, all right, and we know, once again, we could have up or down in this case, whereas this one over here we could have opening right or left. Our equations as follows. We have 4p. Well, what the heck's p? P is actually the distance from the vertex to the focus, which is also the distance from the vertex to the directrix. So 4p times y minus k equals x minus h quantity squared. All right, and the way I remember this is the non-squared term tells you which way it's going to open. So the non-squared term in this case is the y, so it opens up and down because y goes up and down. All right. When we talk about opening up and down, the 4p term would be positive or negative. So the 4p term in this case is either positive here or negative here, and in this case positive or negative. Now if you look at this parabola to the right, it's opening left and right, so I'm looking for the non-squared term of an x, and there it is. And I have 4p x minus h is equal to y minus k squared. So let's take a look at our first example. We're going to find the vertex, focus, and directrix, and then we're going to take and graph this. Now, in order to graph, we're going to need to know one other fact about our parabola. Let's go back. If I take a look at any parabola, it can be the up and down one or the left and right one. If I were to draw a line going through the focus perpendicular to the line of symmetry, it turns out that on either side of that line, I have 2p in distance. 2p here and 2p here. The total distance of 4p is what we call the lattice. Comes up every once in a while. Mostly helps us draw a graph, but that lattice measures from one side to the other in a segment going through the focus perpendicular to the axis of symmetry. So let's go back to this problem now. And we see we've got a center, or a vertex in this case, at hk. H always comes with the x, k always comes with the y. So I have -1 and -2 as my vertex. While I'm doing this, I'm going to take and graph it at the same time. So here's -1 and -2. Put a little dot there. And then I want to know the focus. Well, my focus is going to be found by taking a look at the p term. I know 4p is equal to 8, and I say 8 because p is just a distance. This negative is going to tell us which way it opens. So if we want to include it, I guess we can do that. So p is equal to -2, which tells me that since my non-squared term is y, and I have a negative value, this is going to open down. So I know that in this case, if p is -2, I can go down to, and I will get my focus, and up to, and I will get my directrix. So from this information, I can now write what my focus is and what my directrix is. The directrix is a line going across the x-axis, if you will. All right, so my directrix is an equation of y equals 0, and my focus is this point down here, which is negative 1 over and 4 down. So I've got my vertex, my directrix, my focus. I just have to graph this. Well, I've got a good start here. I'm going to use this 4p idea and move 2p on either side of my focus perpendicular to my line of symmetry. So if p is equal to 2, 2p is equal to 4. So I'm going to move 4 to the left and right. There's 1, 2, 3, 4. Put a dot here. 1, 2, 3, 4. Put a dot here. There's my focus. And I'm going to just kind of connect those in a curvy kind of pattern. And that gets us 3 points to at least start graphing my parabola. I'll label that as 4 here and 4 here. Going to do the same thing, and notice in this case our y term's squared and our x term is the term that is not squared, so that means this parabola is going to be opening to the left since I have a negative in this case. Again, I'm going to look for h and k. My h value is a negative 3, and my k value is a 2, which gets me my vertex. I know my p value, since there's nothing there, reflects a negative 1, so 4p is going to be negative 1, and p is negative 1/4. Start graphing this while I'm at it. I go back 3, up 2, puts me somewhere up here. Now, since my p-value is a negative 1/4, that means, again, my parabola is opening to the left. So I need to move over a quarter from this point, which puts me really close right around here and here. My directrix is going to be moving vertically. So my directrix is a quarter away from that negative 3 value, which puts me at negative 2 3/4. And that is going to give me, since it's a vertical equation, x equals. So now to find the focus, I just have to move a quarter away from this blue dot. So I'm going more negative, which puts me at negative 3 1/4 and 2 for my focus. To graph it from that focus point, I'm going to have to move 2p to either side. Well, if p is negative quarter, 2p is negative half, or 2/4 to both sides. So if I go half up and down from there, and this is 1 and this is a half, you'll notice I have a very narrow opening parabola. Next example. All right, so now we have a parabola that's not in our standard form. It's in the general form. So we're going to need to complete the square in order to get it in our standard form. I prefer typically to isolate all the y's on one side, as you know, and get the x's on the other side. And if I take half of 2 and square that. That ends up being 1. So I'm going to add that to both sides. And now we've created that perfect square of y plus 1 quantity squared is equal to 8x plus 16. Now I need to get this in standard form, so I'm going to need my 4p term. So I'm going to factor out that 8 and get x plus 2. So now we should be able to take and find everything we need. I have hk of -2 and -1 being my vertex. My 4p term is equal to 8, so p is equal to 2. And since my non-squared term is an x, I know that this parabola is going to open left and right. So let's go over here and start graphing it. Here's -2 and -1. Put a dot there, move 2 to the left and right. I know it's opening horizontally to the right, so I know that this is my directrix and my focus is here. Count to where your focus is. We have a focus at 0 and -1 and a directrix of x equals -4. And then now I just have to graph it. If I know p is equal to 2, well then I have 2p equaling 4. So I move 4 up and down. From that focus point, move up 4, put a dot, move down 4, put a dot, and sketch my parabola. There we have it. Moving forward. For general equations, we just talked about that. We had something that was in non-HK form. Our general equation is said to be x squared plus dx plus ey plus x, whereas if, and this is going to be for a parabola opening up and down, sideways, y squared plus dx plus ey is equal to f. So just what's changing here is the x squared and y squared. And that will indicate that we have a horizontal opening for our parabola. So in this problem, rather than being asked to identify where the vertex is, where the line of symmetry is, we're asked to write the equation of the parabola. And we're given that we have a vertex and a focus. So if my vertex is at 5, 0, and my focus is at -7, 0, then I know this parabola has to open to the left, which means that I have some y squared function. Gonna have to input my 4p term right here, and I know that that's going to have to be negative. And then I'll have my x value right here. So I take a look at the distance between the vertex and the focus, and I see that this distance here is a total of 12. And 12 happens to be my p distance. So 4p then is 4 times 12, or 48. And since it opens to the left, that's got to be negative. My x value is 5 over. So that's -5. My y value is 0 up, -0. So we get y squared is equal to -48 times the quantity of x minus 5. And that's the equation of that parabola. Moving to the next example. Now we're given a focus and a directrix. In this case, my focus is at the point 2, 2. So I'm going to go over 2 and up 2. and this is going to be my focus point. Just mark that with an F. The directrix is x equals 10. So I move over here, call this point 10. X equals is a vertical line. And I know that my vertex has to be somewhere in between these two. And it also has to, the parabola that is, has to open around the focus. So it has to be somewhere in this region this way. Again, I'm going to have some y squared function followed by a negative 4p term and an x value here. So in this case, I now have p distance to my vertex and p distance from my vertex to my directrix. So that means the vertex has got to be dead center between 10 and 2. I've got a total of 8 here, so that puts me 4 away. Therefore, 6, 2 is my vertex. So I can start filling some things in. I move over 6. I move up 2. We said y has to be squared. 4p is going to end up being 16. We're done for the day. There are your questions. Get them answered, and we'll see you tomorrow.